It may seem that the derivation of Dirac's wave equation by introducing a few operators with no much important and significant physical basement may awkward. However, the success of the Dirac theory were exemplary to overdo all these drawbacks or all these proposed drawbacks. So we'll now move on to the success of Dirac theory that can be summarized in three different titles. First of all, it introduces for the first time in physics the concept of spin associated with free particles. And this comes as a consequence of the discussion of the plane wave solution of Dirac equation. Plane wave solution is essentially the free particle solution for the wave function that is being followed by or being obeyed by the free Dirac particle. And it's found that such a free particle will be always associated with a spin that's equal to half. This concept of spin was there, however, the concept of spin being possessed by free particle was something new as long as physics is concerned. And it for the first time in physics then gave rise to the concept of spin being possessed by microscopic particles. Second success of Dirac theory originate from the very nature of this spinning motion executed by the charged Dirac particles. Say for example electron, which is a spin half particle, and as you know spin half particles is a class of fermions. Fermions are having half integer or half odd integer spin. When you consider an electron, which is first and foremost example for a Dirac particle, whether it is free or it is being bounded to the attractive pull of a nucleus, it's inevitable that it will have to spin, as spin is an inherent property of this kind of Dirac free particles. Then such a particle which is charged undergoing spinning will be then equated as a current loop and will be always associated with a magnetic moment. And once we discuss the non-relativistic limit of Dirac equation, we will identify that the electron will be possessing this magnetic moment. So the theory also predicts non-zero magnetic moment for electron. However, the concept of negative energy still persisted, but Dirac was clever enough to introduce a reinterpretation under the title The Whole Theory that was sufficient to overdo this difficulty of going with a negative energy particle. This, for the first time in physics, introduced the concept of existence of antiparticles and was strongly being supported by phenomena like pair production, pair annihilation, vacuum polarization, and was further experimentally supported by the discovery of positrons. These are the antiparticles of electron by Anderson in 1932. So we will look into them one by one. First of all, the plane wave solution of Dirac equation. As the Dirac equation involved the operators alphas and beta, which are 4x4 square matrices, the solution satisfying this equation must be a 4-component column vector. Such a 4-component column vector, as we know, is referred to as a 4-component spinor. And the significance of this 4-component spinor is that each and every component of this column vector corresponds to one possible degree of freedom associated with the particle. So, as such a Dirac particle must have 4 different degrees of freedom. The 2 degrees of freedom are already known. These are the one corresponding to positive energy, second one corresponding to negative energy. What the remaining 2 degrees of freedom, 2 possibility of modes of energy possession actually imply to, is exactly that we want to now talk about. For that, consider the Dirac Hamiltonian. H equal to, this can be written in terms of, say, the derivation with which we started in the beginning. we have taken E equal to C root of P square plus M square C power 4 or C root of P square plus M square C square 4 raised to half is square root. Now to get around this act of squaring within this bracket and taking the square root, we have introduced the operator is alpha. So once alpha and beta operate over this bracket, you can write this as say alpha dot p. P square will be vanishing and square root alpha also will be vanishing. And introducing beta here as a coefficient will make this beta m square c square root of m square c square as a mc square. So the Hamiltonian may be written as C into alpha x px. Here also it is evident C into minus IH cross dou by dou x is alpha px plus py plus pz whole square. With the introduction of alpha, you can omit this square and this square root. So this becomes alpha 1 IH minus IH cross dou by dou x, that is alpha x px plus alpha y py plus alpha z pz, which is being written as a alpha dot p. H cross c by I is within this bracket. Once you take h cross c by I into the bracket, this is essentially alpha x px plus alpha 2 h cross c by I dou by dou x2 is alpha y py plus alpha z pz, that is alpha dot p. C is there outside plus beta mc square. So the Hamiltonian format can be written in this manner as well. H equal to C into alpha dot p plus beta mc square. Now for a free particle, at that time the only component of momentum known was the orbital angular momentum L. But we know that the total angular momentum needed to be represented by means of J, that is equal to the orbital angular momentum L plus the spin angular momentum S. However, at that time there was no question on spin angular momentum. The only angular momentum known was this orbital angular momentum. So there was no question on J as well as S at the time where Dirac introduced this interpretation. So the only component of momentum known was L, and for a free particle this orbital angular momentum needed to be a constant of motion. From the mathematical framework of quantum mechanics, we know that a variable or an operator corresponding to a dynamical variable will be a constant of motion provided that operator commute with the Hamiltonian of the system. So we will check whether this angular momentum operator commute with the Hamiltonian of the system. For that we will have to evaluate commutator HL. That's equal to commutator H, Lx plus Ly plus Lz. L is a 3-component operator. Now decomposing this commutator into its components, commutator HLx plus commutator HLy plus commutator HLz, where Lx, Ly, Lz can be evaluated using the relation L equal to R cross P. This you have already done while you talked about chapter number 3, angular momentum in quantum mechanics 1. And H is the relativistic Hamiltonian or Dirac Hamiltonian, C into alpha dot P plus beta mc square. And this dot product involved 3 different terms, alpha x px plus alpha y py plus alpha z pz. So evaluating this commutator is a lengthier task. So let's take first of all one among these 3 commutators that are to be evaluated, and similar expressions can be written for the remaining 2. So let's, for the sake of convenience, let's take commutator HLz. That's equal to C into alpha dot P plus beta mc square. Lz is, of course, you can write xpy minus ypx, but we already have this giving you a scope for decomposing this into further 2 commutators, as this involves 2 different terms in terms of say Lz. Then commutator C into alpha dot P Lz plus commutator beta mc square Lz. Of course, mc square is a constant, and beta is an operator that is neither space nor time independent, whereas Lz is an operator that is exclusively depending upon space and time. So an operator beta which is independent of space and time will be commuting with any operator that do depend on space and time. So this commutator vanishes. Commutator beta mc square Lz is equal to 0. So So we have to evaluate this part, that is commutator C into alpha dot P is alpha x Px plus alpha y Py plus alpha z Pz, comma we replace Lz as x Py minus y Px. Commutator now involved here, the prefactor involved 3 different terms and postfactor involved 2 different terms. Overall we will have to decompose this into 3 plus this one commutator, this one second commutator. So each term in this first commutator, prefactor, will be producing 2 commutator brackets. So overall there will be 6 different commutator terms. However, this will give you a non-vanishing contribution only in the case of those alpha x has nothing to do with px, x or py, because alpha x or alpha y or alpha z are operators that are independent of space as well as time coordinate. So the only non-vanishing contribution arises from the various possibilities of commutators between px, x, py, y and pz, z. However, in this there are some restrictions. We know that non-vanishing commutator being originating from the Heisenberg's commutation relations involve those commutator between the position components and the momentum components having the same direction. That is commutator x Px equal to commutator y Py equal to commutator z Pz equal to IH cross. All other commutators, commutator x Py or y Pz or z Px, all those commutators are zeros. So we will have to look into those commutators that involve these 3 commutators in the decomposition. For that, consider this term alpha x Px that will produce 2 commutators with the post factor of this commutator bracket. That is first one with the x Py, and in this case there is a scope for the occurrence of commutator x Px. So this term needed to be retained. Now in this case, second bracket upon opening with alpha x Px and y Px, there is no question of any of these commutator occurring because you have y and Px here. And in this case there is Py. Here there is y. So this product term will be relevant, whereas this one into this one will not be relevant. Alpha z Pz has nothing to do with the x position coordinate or y position coordinate. So the only non-zero commutators that will be contributing to this will be the term involving the product of alpha x Px and x Py, this commutator, and alpha y Py and minus y Px, this commutator. So we write these 2 terms. So C is taken out, bracket A curly is opened, commutator alpha x Px x Py plus alpha y Py comma minus y Px. This minus is also written within the commutator bracket. Of course, in the next step we can take it out. Now we know that commutator, this is of the form commutator AB comma CD, and that can be expanded into a total of 4 different commutator terms. However, only those commutators that involve commutator x Px needed to be retained. All remaining will be vanishing contributions. You can have, say, a commutator alpha x into Px Py. However, commutator alpha x is 0. Another commutator alpha x Py into x Px, that is also 0. However, there will be a non-vanishing commutator between Px and x. Now alpha x is written here, commutator Px, x and Py is written here. Prefactors are written as prefactors and postfactors are written as postfactors here. Plus here also there will be only one non-vanishing contribution, that is the commutator between Py and minus y. So we have taken alpha y as a prefactor, commutator Py minus y Px outside the commutator. These are the only two non-zero contributions. Now commutator XPX is IH cross, then commutator PXX is minus IH cross. We replace this by minus IH cross, C is retained, minus IH cross is a constant, alpha x will be commuting with this constant, alpha x and Py is here, plus commutator, that is minus IH cross alpha x Py plus commutator Py minus y. Commutator y Py is IH cross. So commutator Py is minus IH cross. So commutator Py minus y is plus IH cross. So IH cross, this is IH cross. IH cross is written here since it's a constant, alpha y Px. That is IH cross is common, which is taken out. Of course, minus IH cross is taken out. Minus IH cross C is already there into alpha x Py minus alpha y Px. This is the Z component of a possible alpha cross P cross product, alpha P cross product. That will have X component I, J, K, alpha X, alpha y, alpha Z, and Px, Py, Pz. This is alpha x, alpha y, and alpha Z. Now the Z component of alpha cross P will be then alpha x Py minus alpha y Px. So this is essentially Z component of alpha cross P. Similarly, we can show that commutator HLX is minus IH cross C into X component of alpha cross P. Since commutator HLZ is found to be minus IH cross C into Z component of alpha cross P. Then commutator HLY will be equal to minus IH cross C into Y component of alpha cross P. Or commutator HL will be equal to the sum of these three different terms, that is commutator HL is equal to, you have to add all these things, minus IH cross C is common, minus IH cross C is taken out into X component of alpha cross P plus Y component of alpha cross P plus Z component of alpha cross P. That is alpha cross P. That means commutator HL is not equal to 0. That means angular momentum, orbital angular momentum is not a constant of motion as long as a free Dirac particle is concerned. But we require that for a free particle, this total angular momentum needed to be a constant of motion. And orbital angular momentum is found to be not a constant of motion. Instead, that is found to be, say, equal to this one. The only possibility then is that it is the total angular momentum that become a constant of motion. So the total angular momentum must not be represented by means of the orbital angular momentum. There will be one more term corresponding to the total angular momentum. This necessitates the angular momentum to be represented as a J, which is the sum of this existing orbital angular momentum and a new component of angular momentum. Once you add this new component of angular momentum with L, then L plus S equal to J will be a constant of motion and commutator HJ will be equal to 0. Commutator HL is equal to this one. For the new addition to be added with L, make it say commuting with H, then S will be equal to the negative of this one. That means S is equal to IH cross C into alpha cross P. Suppose then what happens, commutator commutator HJ, that's equal to commutator HL plus commutator HS. HL is already this one, then commutator HS is the negative of this one. Overall, adding will result in, say, equal to 0. That means the total angular momentum is to be represented as the sum of the orbital angular momentum and the spin angular momentum. Yes, this is now onwards will be treated as spin angular momentum. Why it is called spin? We will come to it very shortly. Following this, Dirac introduced a theory referred to as Dirac spin theory. According to this theory, S needed to be taken as spin angular momentum. S is a vector having three different components, Sx, Sy and Sz. These components are such that they are also happens to be angular momentum components. So do they obey the definition for angular momentum in terms of the anti-commutation rules? This you have already seen in angular momentum in semester 2. Commutator Lx Ly equal to IH cross Lz and anti-commutator Lx Ly equal to 2 Kronecker Ij. Similarly, components of spin angular momentum are such that anti-commutator Si Sj equal to 2 times Kronecker Ij. And this angular momentum, orbital spin angular momentum are defined such that they obey the same definition for angular momentum operators. Commutator Li Lj equal to IH cross epsilon Ijk Lk. Similarly, commutator Si Sj equal to IH cross epsilon Ijk Sk. And the third postulate of Dirac spin theory, components of S commute with components of L, since these are all both S and L are angular momentum operators. Fourth one, J commute with H, so that commutator Hs is equal to negative of commutator HL. Commutator HL is minus IH cross C into alpha cross P. So commutator Hs must be equal to the negative of that quantity, that is minus IH cross C into P cross alpha, or IH cross C into alpha cross P. I have altered P cross alpha here. Once I alter this as alpha cross P, an additional negative will be generated, which make it overall positive. And S is an intrinsic property, unlike the orbital angular momentum, which arises from the revolution of the free particle or the system about a potential center, whereas spin is an inherent property or an intrinsic property of the material to undergo a rotation about its own axis. And Si is such that this is equal to, upon taking the cross product of these components alpha cross P, you can find, see, this is alpha cross P, and alpha cross P will have three different components. First component will be along this alpha y pz minus alpha z py. Similarly, there will be y component and z component. Each and every component in this category, Si may be written as a minus IH cross by 2 into epsilon ijk alpha j pk. For this is minus IH cross by 2 into epsilon ijk will have Levi-Civita symbol, that will have a value equal to 1 upon even permutations. Once these permutations are even, 0 sigma k 0, that is alpha j, sigma j 0, that is alpha j, and alpha k 0 sigma k 0. This is minus IH cross by 2 into, upon opening this 0 into 0, 0, sigma I, sigma k, sigma j, sigma k, that is I, sigma I. This is the first entry to this matrix product. Second entry will be 0 into sigma k, sigma j into 0, that is 0. This entry will be sigma j into 0 plus 0 into sigma k, 0. Sigma j, sigma k, that is I, sigma I. That is a property of the polyspin matrices. Sigma x, sigma y is I, sigma z cyclic. That's equal to H cross by 2 into, this I is taken out, minus I, and I will be making it a plus 1, H cross by 2 into sigma I 0, 0, sigma I. This is the polyspin matrix along the ith direction. So this is H cross by 2 sigma D. Whereas instead of calling this polyspin matrix, Sigma I is Pauli spin matrix. However, sigma I 0, 0, sigma I is a 4 by 4 matrix which is referred to as the Dirac spin matrix, sigma D. Eigenvalues of this spin, S square is equal to, S square will be equal to h cross by 2 whole square into sigma D square. Sigma D square is identity, so this is h cross square by 4. For S square minus h cross square by 4 I equal to 0. That means S plus h cross by 2i into S minus h cross by 2i equal to 0, or S equal to plus or minus half h cross. The eigenvalues of this spin operator is plus or minus half h cross. This is why this angular momentum needed to be referred to as the spin angular momentum and can have two different degrees of freedom corresponding to plus half h cross and minus half h cross respectively, and are indicatives of clockwise and anti-clockwise spinning motion. So these are the two remaining degrees of freedom associated with the free Dirac particles. So there are 4 degrees of freedom. We now find that 2 degrees of freedom are associated with the spinning motion, and the remaining 2 degrees of freedom we already speculated as these are corresponding to positive energy and negative energy. Positive and negative energy. Of course, we will verify that the remaining 2 degrees of freedom now corresponds to positive and negative energies. For that, consider the free particle solution to Dirac equation psi equal to psi 1, psi 2, psi 3, psi 4 equal to the space dependent probability parameters may be written as u1, u2, u3, u4 into free particle wave function, which is e raised to I by h cross into p dot r minus et. The free particle is associated with only kinetic energy and moment. E is the kinetic energy and p is the momentum. So these two parameters are in soaked in it. This we have already seen while we talked about the Klein-Gordon equation. Now, taking z axis along the direction of propagation, then px equal to py equal to 0, and p has the meaning of say pz, p dot r has the meaning of px x, px x plus py y plus pz z. Since px and py are 0, there will be only pz into ez. So p equal to pz and r will be modifying as a ez minus et. Now consider the Hamiltonian form of Dirac equation. E psi equal to c into alpha dot p plus beta mc square psi. That is E into psi is this one with p equal to pz and r being modified as a z only. So E psi equal to c into alpha dot p also will have the meaning of alpha z p z, since px and py are 0 and pz is being marked as a p here. So c into alpha dot p is c into alpha z pz, or c into alpha z p. Pz has the meaning as a being represented by p plus beta mc square operating over e, psi. That is E into this term and this term will be vanishing. What remains is E into u1, u2, u3, u4, c into alpha zp. Alpha z is 0, sigma z 0 into p plus beta mc square is, this is beta identity 0, 0 minus identity mc square u1, u2, u3, u4. Now opening this bracket, E u1, u2, u3, u4 equal to, we open this bracket, 0 into p into 1, that is pc here, minus pc here, pc here, minus pc here. All remaining entries are zeros. Plus mc square will be along the diagonal, mc square here, minus mc square and minus mc square here. And the remaining terms will be 0, u1, u2, u3. Again, combining these two, 0 plus mc square u1, of course we will put aside for this opening, mc square 0, pc 0, 0 mc square. Along the diagonal, these entries will be modified from 0 to along these diagonal entries. Now again, comparing the identical terms on both sides, E u1 will be equal to mc square u1 plus 0 u2 plus pc u3 plus 0 u4. That is mc square u1 plus pc u3. E u2 on the left side will be equal to, along this row and this column, we have to open to find out the entry corresponding to this second entry on the left side. 0 into u1, u2 mc square, 0 u3 minus pc u4. mc square u2 minus pc u4. E u3 will be equal to pc u1 minus mc square u3. pc u1 minus mc square u3. E u4 is equal to 0 u1 minus pc u2 minus pc u2 is written here. 0 minus mc square u4 minus mc square u4. For rearranging these equations as this first equation contains u1 and u3, combining the terms containing u1, we get it e minus mc square u1 minus pc u3 equal to 0. Similarly, this term contains two u2 terms and one u4 term. Here this contains two terms with u3, and in this case there are two terms with u4. So combining them in the format of a homogeneous equation, we get e minus mc square u1 minus pc u3 equal to 0, e minus mc square u2 plus pc u4 equal to 0. From the third one, this becomes pc u1 plus e plus mc square u3 equal to 0, pc u2 plus e plus mc square u4 equal to 0. For writing this in the format of the matrix equation, e minus mc square, there is only u1, there is no u2, so 0 u2. There is u3 minus pc is written here. u4, there is no coefficient 0. And from this, there is 0 as coefficient for u1 and u3. And for u2, this is e minus mc square. For u4, this is pc. And we repeat this for the third equation and fourth equation as well. To rewrite this in the format of the matrix equation, matrix coefficient matrix into the quotient matrix equal to 0. In order that a non-trivial solution occur, the Wronskian, that is the determinant of the coefficient matrix, should be equal to 0. We equate this to 0. This is now a 4/4 determinant. This is to be opened along the first row. E minus mc square into the row and column corresponding to e minus mc square is removed to obtain the cofactor. Cofactor determinant is determinant e minus mc square 0 pc 0 e plus mc square 0 pc 0 e plus mc square. Minus this term is 0, so there is no question of an expansion corresponding to this. And minus pc, this term is actually plus pc, but here it is minus pc, so minus pc is written. The row and column containing this term is removed to obtain the cofactor matrix 0 pc 0 e minus mc square 0 pc e minus mc square 0 pc is here, pc 0 e plus mc square, that's equal to 0. Now we open this e minus mc square into e minus mc square into, we eliminate the row and column containing this one, e plus mc square into e plus mc square, e plus mc square whole square, e plus mc square whole square minus 0 into 0, so it is not written. Now minus 0 into this one, that is 0, plus pc into this one, pc is written here into 0 minus pc into e plus mc square, pc into e plus mc square. So this part is over. Now this one, minus pc into along this row and column, this is 0, so it is not required. Minus of e minus mc square, minus of e minus mc square into, eliminating the row and column containing this, what remains is pc into e plus mc square minus 0, that is pc into e plus mc square, plus pc into the row and column containing this element is eliminated to obtain the cofactor matrix, determinant pc into pc minus 0, that is p square c square. Now that's equal to 0. We will have to simplify this. E minus mc square is common factor, that is taken out, e plus mc square into e minus mc square into e plus mc square plus pc into minus pc. And from the second term, Pc can be taken as a common factor from this one as well as from this one. So overall, outside the bracket, this becomes P square C square since there is already a Pc into. Here what remains is E plus mc square into E minus mc square with a minus sign. This minus sign is written here. E minus mc square into E plus mc square plus P square C square is there. Now we take E minus mc square into, again simplify this, E plus mc square into E square minus m square c power 4 minus P square C square. That is a minus b into a plus b. This one, a square minus b square. So that is written here. Plus pc into minus pc, that is minus p square c square. Plus here it is p square c square. With a plus sign, we take this minus outside to make it set plus p square c square into e minus mc square into e plus mc square. That is e square minus m square c power 4. And upon taking a minus out of this bracket to make this minus sign plus, this term becomes minus p square c square, that's equal to 0. Now this bracket is common to both these terms. This term is common, so this is also taken out. E minus mc square into e square minus m square c power 4 minus p square c square into e plus, actually this is, once you take this term outside, this is taken out. E square minus m square c power 4 minus p square c square. This term is taken out. Into what remains here, e minus mc square into e plus mc square plus p square c square. So actually this is e minus mc square into e plus mc square plus p square c square. That is now, here there is a mistake, this term is not here. This term is taken out. What remains is e minus mc square to e plus mc square in the first bracket and plus p square c square in the second bracket. And upon multiplying e minus mc square and e plus mc square, you get it a minus b into a plus b. A square, which is e square, minus b square, which is m square c power 4 plus p square c square. So this term becomes e square minus m square c power 4 minus m square c power 4. Here it is minus. This term is not here at all. E square minus m square c power 4 plus p square c square equal to 0. This equal to 0 means either this is equal to 0 or this is equal to 0. If you take this one or this one, both will have the same meaning. So we take this one equal to 0. That is e square minus m square c power 4 minus p square c square equal to 0. That means e equal to p square c square plus m square c power 4. E square equal to this one, or E equal to root of p square c square plus m square c power 4, or this is equal to plus or minus EP. So here also the positive and negative energy states continues. Now we have to substitute E equal to plus EP and E equal to minus EP to evaluate the values of U. When you substitute, that is the eigenvectors, when you substitute EP positive, U prime becomes A0, B0 and U2 becomes 0A, 0 minus B, where A equal to 1 by root 2 into 1 plus MC square by EP raised to half and B equal to 1 by root 2 into 1 minus MC square by EP raised to half. When the negative value of EP is taken, U3 becomes minus B0, A0 and U4 becomes 0B, 0A. Here also A and B has the same meaning. So this gives you an evaluation of the 4 components of the spinor corresponding to positive energy and negative energy. So this gives the plane wave solution for Dirac equation, and as an important outcome of this solution we find that 2 degrees of freedom of the free Dirac particles corresponds to positive energy states and negative energy states, and the remaining 2 degrees of freedom corresponds to spin half, plus half and minus half. So as a consequence of this discussion, we come to the conclusion that the spin possessed by microscopic particles, some microscopic particles, particularly electrons, is an intrinsic property of these particles. If such an intrinsic property of spinning around its own axis is exhibited by an electron, then definitely it will be associated with a magnetic moment. This magnetic moment is also proved by Dirac, and this we discuss under the title the non-relativistic limit of the Dirac equation. For that, consider the Dirac equation in Hamiltonian form: E psi equal to C into alpha dot P plus beta mc square psi. In an electromagnetic field with field parameters scalar potential phi or electrostatic potential phi and vector potential A, the energy as well as momentum of the system changes. Energy changes from E to E minus phi, E to E minus E, charge of electron into potential, and momentum changes from P to P minus EA by C. Because the scalar potential directly controls the energy, whereas the vector potential modify the momentum. Now E minus, then we substitute this modification for energy as well as momentum in this expression, that is the Hamiltonian form of the Dirac equation. E minus E phi psi equal to C into alpha dot P, with P having this modified definition, P minus EA by C plus beta mc square psi. Now psi can be written in coupled form as psi as a component of two components binaries, each phi and chi. Phi has two different components, phi 1 and phi 2. Chi has two different components, chi 1 and chi 2. So psi equal to phi chi. Now phi corresponds to positive energy and chi corresponds to negative energy. In fact, E minus E phi operating over phi chi equal to C into alpha dot P. That is, C into alpha is 0, sigma k 0 into P plus beta I 0, 0 minus I mc square operating over phi chi. That is E minus E phi phi chi equal to, we combine them, C0 into P, that is 0, plus I mc square, which is mc square. C sigma k P plus 0, so that is C sigma kp, and this term will be C sigma kp plus 0, that is C into sigma dot p, sigma k dot p actually, or alpha is the, so this is better to be represented as a sigma instead of sigma k. Once it is sigma k, only one component of alpha dot p is taken into consideration. Minus mc square, C into 0 into p plus minus I mc square, that is minus mc square operating over phi chi. That is E minus E phi phi equal to first component on the left side, and on the right side this component will be mc square phi. Along this row and this column we have to open this matrix product, C into sigma dot p chi, C into sigma dot p chi plus mc square phi. E minus E phi chi equal to C into sigma dot p, C into sigma dot p phi minus mc square chi. Now this representation being marked as a equation 1 and 2 is referred to as Dirac equation in coupled form, because this gives you the negative energy state and the relationship between the negative energy state chi and the positive energy state phi. So phi and chi are involved in both the same equation. Both the same, not both the same equation, but the same equation. This is why this representation is referred to as equation in coupled form. Now from this we write phi equal to C into sigma dot p. Yeah, we can combine these terms containing phi. E minus E phi plus mc square phi equal to C into sigma dot p chi, or phi equal to C into sigma dot p divided by E minus E phi plus mc square. We now replace E as E, the total energy equal to the rest energy E dash plus, the energy in addition to the rest energy mc square. So total energy equal to rest energy mc square plus E dash. Then this is written as a E dash plus mc square, and you take this mc square to the left side to make it say plus 2 mc square. Then this is E prime, E equal to E prime plus mc square. So E prime minus E phi plus mc square plus this minus mc square plus mc square is taken to the left side to make it say again mc square. Overall there will be minus 2 mc square chi, because we have put E equal to E prime minus mc square. So rewriting is E as a E prime minus mc square, where mc square is the rest energy. So E is actually a total energy E prime minus rest energy. Rest energy must be there as a contribution. The additional will be equal to E. So E prime is the total energy. I must have written it as a E equal to E prime minus mc square, or say E prime equal to E plus mc square. Actually I meant it E prime equal to E plus mc square. Anyway, then this term becomes E is E prime minus mc square upon coming from the right side, make it say 2 mc square minus 2 mc square chi. We keep this equation free, and from this E is again written as E prime minus mc square minus E phi C into sigma dot P phi minus mc square chi. We take this also to the left side to make it say plus 2 mc square. So chi equal to C into sigma dot P divided by E prime minus E phi plus 2 mc square phi. Equation 4. In the non-relativistic limit, E minus E phi is much less than mc square. Then this equations becomes E minus E phi is comparatively smaller. Phi becomes equal to sigma dot P, because C into sigma dot P divided by 2 mc square will be there. C vanishes. Sigma dot P by 2 mc into chi for negative energy, and for positive energy chi equal to C into sigma dot P. This is comparatively smaller. Actually this is E prime minus E phi. This is comparatively smaller comparing with 2 mc square, so you can omit this. C vanishes to make it say sigma dot P divided by 2 mc. This we keep equations 5 and 6. Now substitute 6 in 1, we get E minus E phi into phi. That is, this is the first equation. See, this is the first equation, equation 1. We get this E minus E phi into phi equal to C into sigma dot P into C into sigma dot P by E minus E phi plus 2 mc square phi plus mc square phi. And E minus E phi into phi equal to C into C square. However, this is comparatively smaller. E minus E phi is comparatively smaller comparing with 2 mc square. So C square in the numerator vanishes with this one. Sigma dot P into sigma dot P whole square divided by m into phi. Actually, there will be 2m into phi plus mc square phi. That is E minus mc square phi. Take this term to the left side. E minus E phi minus mc square. E minus E phi. In the non-relativistic limit, we omit this term, say E phi term. in the non-relativistic limit or in the absence of potential, the contribution of this is omitted, then this is E minus mc square phi equal to sigma dot p whole square by 2m plus E phi. Yeah, this E phi term is taken to the right side because we will not be able to omit E phi even in the non-relativistic limit because this arises because of the potential. So we rearrange E phi to the right side and mc square to the left side. E minus mc square phi equal to sigma dot p whole square by 2m plus E phi, where this phi is the potential operating over the wave function phi. This we keep equation 7. Now we have this term sigma dot p whole square, that is sigma x px plus sigma y py plus sigma z pz square, which is sigma x px, sigma y py plus sigma z pz operating over this one itself. That is now sigma x px into sigma x px, which is all these components are commuting. Sigma x square px square plus there will be sigma y square py square plus sigma z square pz square. Now the interproduct term sigma x px sigma y py plus sigma y py into sigma x px, sigma x sigma y px py plus sigma y sigma x py px. Sigma are commuting with px as well as py. However, px and py need not be commuting. Actually, px and py is also commuting because commutator px py is 0. So you can write this in any order. Anyway, sigma x square is identity, px square remains. From the second square term, this is py square, sigma y square is identity, where sigma are Pauli spin matrices, or even if these are 4-component Dirac spin matrices, these are valid. However, we have written this in coupled form, so sigma are 2x2 matrices, the Pauli spin matrices. Plus sigma x, sigma y is I sigma z. Here also sigma y, sigma x is there, that is minus I sigma z into px py minus py px, plus the remaining 4 more terms will be there. That is px square plus py square plus pz square, which is p square, plus I sigma z into px py minus py px is x component of p cross p, plus second term will be I sigma x into y component of p cross p, plus I sigma z into z component of p cross p. So this is p square plus I sigma into p cross p, combining the remaining terms as well. But p cross p, as per the modification of momentum p from p to p minus Ea by c, p cross p means p minus Ea by c cross p minus Ea by c. That is p cross p, which is 0, minus p into E by c cross A minus E by c into A cross p, minus minus make it plus E by c into A cross A. A cross A is also 0, P cross P is also 0. So what remains is minus E by c into P cross A plus A cross P. That is minus E by c into P cross A is P is minus IH cross grad. A cross grad has nothing to do with it, so we will have to retain only the first term. This is now minus IH cross del cross A. That is minus minus make it plus IEH cross by C into del cross A. But del cross A for uniform field is B. For del cross A is always B. So this is IEH cross by C into B. So sigma dot P whole square, these terms now become P square, which is P minus EA by C whole square plus I sigma into P cross P. That is I sigma into IEH cross by C into B. I square minus 1 E by C H cross into sigma dot B. Now we substitute this value of sigma dot P whole square in the expression. In this expression, we get E minus mc square phi equal to P minus Ea by C whole square by 2m minus EH cross by 2mc into sigma dot P plus E phi, where this capital phi is the scalar potential and capital A is the vector potential times phi. So in the non-relativistic limit, we can take E minus mc square approximately equal to the non-relativistic energy, which is IH cross dou by dou T. So we replace this IH cross dou phi by dou T, where phi is the wave function, equal to P minus Ea by C whole square by 2m minus EH cross by 2mc into sigma dot P plus E phi operating over the wave function phi. In the classical equation, only these two terms were present. However, as per Dirac equation, this additional term arises, where EH cross by 2mc is one unit of magnetic moment referred to as the Bohr magnetron. So, according to this equation derived by Dirac for electron, inherently there will be this term sigma dot P times 1 unit of magnetic moment, and this corresponds to the non-zero magnetic moment of free electron as an intrinsic consequence of the Dirac theory. Now we will conclude with the discussion of Hall theory. Though there were a lot of astonishing success for the Dirac theory, still there persisted a reinterpretation problem as long as the existence of the negative energy is concerned, since the negative energy term retained for the three-particle solution of Dirac equation. To get around this difficulty, at that time there were no electrons which were found moving opposite to the direction of the field. If there is an electron with a negative energy, the electrons are moving opposite to the direction of the field because of the fact that they have positive energy. If there are electrons that do have negative energy, then at least there must be one electron in an assembly of several thousands of electrons which are moving along the direction of the applied field. Such an experimental fact were never found, and it was very difficult to go with such a situation where a negative energy electron were not even found at all in any of the experimental procedures. To get around this difficulty, Dirac introduced a reinterpretation theory under the title the Hall theory. The Hall theory is based on two hypotheses. These are: the normal state of existence of material particles is referred to as vacuum, and in vacuum there are both positive as well as negative energy states, such that all the negative energy states are completely filled in accordance with the Pauli's principle. According to the Pauli's exclusion principles, no two electrons will be occupying the same quantum state. So, in all negative energy states are filled means all the negative energy states are singly occupied, so that there is no question of an electron having positive energy to returning back to the negative energy states. So, this postulate account for the stability of negative energy state. Since these electrons are already occupied, negative energy electrons are already occupied, there is no question of an electron with negative energy which is found to be, say, moving freely. And the second postulate states that no vacuum as such can be experienced or observed. However, the changes in vacuum or the deviation from vacuum can be observed. That means this corresponds to negative energy states. Negative rest energy of electron minus mc square is shown here, and all these energy states are simply occupied. This is the zero energy state, and here you have electron having positive rest energy mc square. All these electrons are positive energy electrons, and you can see all these positive energy electrons. So you can observe or feel the presence of this positive energy electron. The negative energy electron system is there as an invisible situation or as an invisible world associated with the real world where you feel only positive energy electrons. However, if an electron in the negative energy state gets sufficient energy, of course in the form of photon, it will be get promoted to the positive energy state. Once such an electron, that is positive energy, the negative energy electron, which must be then represented by E plus, moved to the positive energy state, it will be appearing as an electron. However, of course, this is depending upon the presence of a negative energy, positive energy, negatively charged electron vacancy in the positive energy state. However, it is not at all stable here. Either this electron itself or an already existing positive energy electron will have a tendency to return to this vacancy of hole being created. Here also, this is referred to as hole. Only the presence of this hole can be felt. That is why this theory is often referred to as hole theory. So the electron will be returning back to the hole along with the production of a photon having energy equal to the difference of this energy, which is mc square to 0, mc square from 0 to minus mc square, again mc square. So this photon. So the first postulate ascertain the stability of all positive energy states, and this also gives rise to the concept that only positive energy electrons can be felt. And the second postulate give the only possibility where there occur an interaction between positive energy world and negative energy world. When sufficient energy photon strike a negative energy electron, it will be promoted to the positive energy world. However, the loss of this electron, negative energy electron, will create the presence of a positive energy electron in the negative energy world. This positively charged, not positive energy electron will be present in the positive energy world, whereas a positively charged electron will be felt in the negative energy world. This is referred to as a positron, or this vacancy is referred to as a hole, and this will be immediately filled by the bouncing back of an electron or the electron already present in the positive energy world into this hole being created in the negative energy state. For this to happen, the photon must have an energy equal to the difference of this energy, which is 2mc square, and also this act of production as well as annihilation of this hole vacancy in the negative energy world, which will be felt as a positive energy electron in the positive energy world, will be simultaneous, and along with this retaining of a positive energy electron to balance the creation of the positron in the negative energy world will be associated with the emission of a gamma ray photon having energy equal to 2mc square. This kind of a production of an electron hole pair, electron in the positive energy world and the vacancy of electron in the negative energy world being felt as the presence of a positively charged electron, or the so-called positron, which is the antiparticle of electron, is referred to as pair production and is simultaneous with the converse of this process referred to as pair annihilation. Pair production and pair annihilation give strong evidence for the hole theory introduced by Dirac, and further the discovery of positron by Anderson in 1932 implied to the presence of this positively charged electron that is in fact a negative energied electron in the negative energy world gives strong support to the hole theory. That also gave rise to the success of the hole theory. Another important evidence that gave rise to strengthen the hole theory is vacuum polarization. All these electrons in the positive energy world will have a tendency to occupy the negative energy states because of the fact that give them a lesser energy occurrence, and always a lesser energy occurrence give rise to a more stable occurrence. So all these electrons in the positive energy world or all these electrons that are reasonable for the existence of the world also, because a negative energy world is associated with the positive energy world. All these electrons will have a tendency to go to this negative energy world once a vacancy is created. So the creation and annihilation will be then an easier task. To annihilate the entire world, the creator, if such exists, will have to create only some vacancies in the negative energy world, which is associated with the positive energy world. Then all these electrons will have an inherent tendency to go to this negative energy world. However, there are at present no vacancy of electrons in the negative energy world. Though there is no vacancy, they will have a tendency to occupy this region if there occur a vacancy. Then all these electrons, both the electrons in the positive energy world and negative energy world, are fermions and are having spin half. So then these electrons will be suffering a Pauli repulsion pressure. Due to the tendency of these electrons to occupy this region, they always will have a tendency that somebody is attracting them from the negative energy world. As a consequence of this, there will be strong repulsion from the already filled negative energy states or electrons occupying in the negative energy states. That causes an additional repulsion for the electron, resulting in a reduction in their energy. This necessitates the electrons to be occupying a position that is a little bit ahead of the actual neutral position where they need to occupy. ശരിക്കും ഇലക്ട്രോൺ ഇവിടെയാണ് ഇരിക്കേണ്ടത്. അത് ഈ നെഗറ്റീവ് എനർജി വേൾഡ് ഇവിടെ ഇല്ലെങ്കിലാണ്. നെഗറ്റീവ് എനർജി വേൾഡ് ഇവിടെ ഉണ്ടെങ്കിൽ ഈ ഇലക്ട്രോണിന് എല്ലായ്പ്പോഴും ഇങ്ങോട്ട് പോകാനുള്ള ഒരു ടെൻഡൻസി ഉണ്ടായിരിക്കും. ആ ടെൻഡൻസിയെ ഒപ്പോസ് ചെയ്യുന്നത് ഇവിടെയുള്ള പോളി പ്രഷറാണ്. ഇവിടെ ഓൾറെഡി ഉള്ള ക്വാണ്ടം സ്റ്റേറ്റ്സുകളെല്ലാം ഫിൽഡ് ആണ് എന്നുള്ള പോളി പ്രഷറാണ്. അങ്ങനെ പോളി പ്രഷർ ഉണ്ടാവുമ്പോൾ ഇവിടെ ഇരിക്കുന്ന ഇലക്ട്രോൺ ശരിക്കും ഇവിടെ ഇരിക്കേണ്ടതല്ല, കുറച്ചുകൂടെ താഴെയാണ് ഇരിക്കേണ്ടത്. കുറച്ചും കൂടെ തള്ളിയിട്ട് അപ്പുറത്തായിട്ടാണ് ഇത് ഇരിക്കുന്ന പ്രതീതി ജനിപ്പിക്കപ്പെടുന്നത്. This separation of electron beyond their actual neutral point is referred to as polarization and is resulted from the vicinity of vacuum to them, and hence is referred to as vacuum polarization. This can also be found as an additional correction in energy in some sophisticated spectroscopic studies. This vacuum polarization also gives rise to the success of the whole theory, and that further in turn give rise to the success of the Dirac theory. Now there are spin half particles that do have zero rest mass. So we came to the conclusion following the discussion of the success of the Dirac theory that electrons are the particles that are satisfying or obeying the Dirac equation, and hence are often referred to as Dirac particles. For Dirac particles are spin half particles. However, there are spin half particles that do have zero rest mass, so that their rest energy m0 square will be equal to 0. That kind of particles are neutrinos and antineutrinos. They do also satisfy a relativistic wave equation. The relativistic wave equation satisfied by neutrinos is referred to as Weyl equation. To derive Weyl equation, you consider the Dirac equation in Hamiltonian form and substitute m equal to 0. When m equal to 0, E psi equal to c into alpha dot p psi. And here also there are 2 degrees of freedom corresponding to positive energy and negative energy. It's that when you have antineutrino, and the remaining 2 degrees of freedom corresponds to a new parameter referred to as helicity. Helicity is defined by h equal to sigma dot p divided by p, and is a concept that is related to parity. So the 2 degrees of freedom possessed by antineutrinos and neutrinos corresponds to helicity. depending upon the direction of sigma dot p and p, whether p and sigma dot p has the same direction or anti-parallel to each other, helicity can have 2 degrees of freedom. So 2 degrees of freedom of Weyl particle corresponds to helicity, and the remaining 2 degrees of freedom corresponds to positive energy and negative energy. So with that we come to an end for this discussion, and that's all about this module. In the exam point of view, this is very important. Most often essay questions are, you may be asked to discuss the entire success of Dirac theory in these 3 points, or you may be asked to discuss the free particle solution of Dirac equation, where you will have to derive first of all the 2 degrees of freedom corresponding to spin, and remaining 2 degrees of freedom corresponding to positive energy and negative energy. Or often you will be asked to discuss the Dirac equation being satisfied by the electron, and you may be asked to interpret the non-zero magnetic moment for the electron. Hall theory is often asked as a short answer question, that is never an essay question. And sometimes you may be asked to derive the Dirac equation also. Along with that, you may be asked to derive the continuity equation satisfied by the Dirac equation. Problem, I already have given you a note. Please go through the problems mentioned in that note. The often problem is you may be asked to find the commutator alpha x, alpha y, alpha z, for commutator alpha x, alpha y, beta. All these are how to be say 0. You can evaluate this simply using the commutation, anti-commutation rules satisfied by them. Now short answer questions, a lot of short answer questions may be asked from relativistic quantum mechanics. Yeah, one more problem, you may be asked to derive the Klein-Gordon equation, the energy eigenvalues of Klein-Gordon equation, the interpretational problem associated with the Klein-Gordon equation, the continuity equations as satisfied by Klein-Gordon equation, the non-relativistic limit of Klein-Gordon equation corresponding to Schrodinger equation. Now short answer questions, you may be asked to derive the again Klein-Gordon equation. You may be asked to discuss the Hall theory and the experimental evidence for Hall theory. You may be asked to list the properties of Dirac operators. Another short answer question can be, what are the salient features of Dirac spin theory? Another short answer question can be the redefinition for scalar product in the language of Klein-Gordon vector space. So these are the most often questions. So the module is rather important. Go through these video lectures, go through the notes that you might have already collected. You can expect 1 essay, 2 short answer, and 2 problems from this module. With this, we come to an end for this discussion on relativistic quantum mechanics. We will have a 1 hour more lecture to talk about the scattering problem. If you are hectic with the content, you can skip the discussion on scattering and you may go through the remaining 4 modules. With that, we conclude. I wish you all nice experience for your upcoming examinations. Thank you.